Okay, now we are on to ACE Investigation 3, homework, and this is problems 9 through 14 here. Triangle ABC is similar to triangle PQR. For exercises 9 through 14, use the given side and angle measurements to find the indicated angle measure or side length. So to find angle A, all we simply have to do is add up 64 degrees plus 49 degrees. Add that together, take that amount, and then we subtract it from 180 degrees. Because the sum of the interior angles of a triangle is 180 degrees. So the answer to 9 is 67 degrees. And excuse the little mark. I know that's not a degree mark that's right here, but we'll just pretend that's degrees because I don't have the degree sign on my iPad. So we'll just say this is 67 degrees. Okay. For angle P, what we do is, since these are two similar triangles, which is indicated up here, that these two are similar to each other, that means that angle P is going to be the same as angle A. Therefore, it is also 67 degrees. Okay, so for 13, the length of side AC. So if we look for the length of side AC right here, then that means it is going to be similar, or it is going to have a scale factor that we need to find of PR. So side BC is going to be similar to QR. And since we're given that the side BC is 46 inches, we divide that by 23 inches in QR, and then we get a scale factor of 2. So we multiply 22.5 times 2, and that's going to give us 45 inches. Okay. All right, now for 10, angle Q. Angle Q is corresponding with angle B. So we just simply say that angle Q is 64 degrees right there because angle B is 64 degrees. Okay, length of side AB for number 12. So here's AB is this side, and it corresponds with QP. We know our scale factor is 2, so we simply multiply 19 times 2, and that'll give us 38 inches. Alright, last one, number 14 in this section. We're finding the perimeter of triangle ABC. So to find the perimeter, what we need to do is to add up all the sides. Now we know that BC is 46 inches because that's given to us. Side AC is 45 inches, which you found out down here. And side AB is 30 inches. So when we add all that together, that gives us 129 inches. Okay, on to 15, 16, 17, and 18. These are multiple choice questions, and we're going to use the parallelograms that are listed right here. Okay, so for 15, what is the measure of angle D? Well, angle D corresponds to angle Q, and that's given to us 125 degrees, so that means that it is answer C, 125 degrees. Alright, so what is the measure of angle R? Okay, angle R is sitting on the same straight line as angle Q. And as we learned, if we have a straight line, that is a 180 degree line. You always say that the straight line is 180 degrees. So 180 degrees minus 125 is going to give us an answer of 55 degrees. So that is the measure of angle R for number 16. Okay, so what is the measure of angle S? Since this is a parallelogram, we can make the assumption that this angle and this angle are exactly the same. This angle and this angle are exactly the same. So if S and Q are the same angle, they have the same degrees, then that means that angle S will be 125 degrees. Let's see, 18. 18 asks us, what is the length of side AB in centimeters? Well, you can approach that one of two ways. Since it's a parallelogram, we know that the length of CD is going to equal the length of BA, or AB. So that will automatically make the answer H, which is 15 for centimeters. Or you can go the scale factor route, since we know that these parallelograms are similar. 15 divided by 7.5 will give you a scale factor of 2. Okay. Then all you have to do is just add that back and say, okay, SR is the same as BA. I know that SR is 7.5 centimeters, so I multiply it by 2, and then I get the 15. Okay, number 19. Suppose a rectangle B is similar to rectangle A below. If the scale factor from rectangle A to rectangle B is 4, what is the area of rectangle B? There's two ways that you can do this. The first way is to get the dimensions to rectangle B. So, since our scale factor is 4, that means that our new dimensions are going to be 3 times 4 is 12 by 4 times 4, 16. And to find area, that's going to equal length times width, and that's going to give us 192 centimeters squared. Okay? So that's the first way you can do it. The second way that you can do it is to find the area of rectangle A, which is 12 centimeters squared. And then you're going to multiply that by the area scale factor, which is a little bit different. So that means we need to square the 4. So the scale factor for area equals 16. And then once again, you multiply 12 by 16, and you get the same 192 centimeters squared. Okay, number 21. Suppose rectangles X and Y are similar. The dimensions of rectangle X are 5 centimeters by 7 centimeters. The area of rectangle Y is 140 square centimeters. What are the dimensions of rectangle Y? Okay, so the first thing we need to do here is see how I kind of drew out the different rectangles just so I can get a visual, because I know that that helps me when I look at a visual. So let's find the area of rectangle X. The area of rectangle X is going to be 5 times 7, so that's going to give us 35. Alright, oops, let me go to the pencil. 35 centimeters squared. Alright, so this is 35 centimeters squared. Okay, so then we find the area scale factor. So 140 divided by 35, so the area of rectangle Y divided by the area of rectangle X is going to give us 4. So the square factor for area is 4. So if we want to figure out the dimensions, that means we need to find the square root of 4. Okay, and that equals 2. So the scale factor is 2. Now simply we just multiply 5 times 2 and 7 times 2. So when we do that, 5 times 2 is 10. And then 7 times 2 is 14. So the dimensions of rectangle Y are 10 by 14. Okay, 32A. Suppose the following rectangle is reduced by a scale factor of 50%. What are the dimensions of the reduced rectangle? So, our reduced rectangle, scale factor is going to be 50%, or 0.5. Okay, so 0.5. So we just need to multiply the dimensions by the scale factor. 8 times 0.5 is going to be 4. 12 times 0.5 will be 6. So the dimensions of the reduced triangle are 4 by 6. Now let's go to B. Suppose the reduced rectangle in part A is reduced again by a scale factor of 50%. Now what are the dimensions of the rectangle? So that means we're going to take the image that we just made. We'll make another smaller rectangle over here, little baby rectangle. And we're going to reduce it again in half. So the scale factor between this rectangle and this rectangle is also going to be 0.5. So that gives us dimensions of 2 by 3, because we just divided 4 divided by 2, and 6 divided by 2 equals 3. So 2 by 3. C. How does the reduced rectangle from part B compare to the original rectangle from part A? Alright. From the original rectangle to this second image that we made, the scale factor is going to be 1/4. Okay, or 25%, however you want to say it. Okay, because we take 8 and we multiply it by 25%, we are going to get 2. If we take 12 and multiply it by 25%, we're going to get 3.